Welcome to the section Styling React Native. In this video, we are going to introduce FlexBox. The aim of this video is to introduce FlexBox within React Native. We will cover the basics of FlexBox and its container properties, and then we will experiment with those properties. CSS in React Native is different than how it's utilized on the web. The difference between React and React Native when it comes to CSS is that on the web, using React, there aren't any specific standards that need to be followed. In our case, when using React Native, there's a standardized approach for how to style. There are no CSS strings, but we are able to achieve styling by adding them inline as JavaScript objects, or using the React Native style sheet component. The style sheet component allows you to create a style sheet and pass it into your components and utilize specific styles based on the name applied to that object. Another major difference is that only a subset of CSS props are supported, and certain props can only be used on certain platforms. The last thing I would like to point out is that React Native relies on FlexBox for layout. So now the question is, what is FlexBox? The Mozilla Developer Network defines FlexBox as a one-dimensional layout model, and as a method that could offer space distribution between items in an interface and powerful alignment capabilities. In short, this is extremely beneficial to React Native because it's a layout method that understands how to utilize the available space inside of a container and distribute it amongst its children. FlexBox also understands how to grow and decrease in its size as items are removed from a container. Due to a mobile phone's limited screen space, understanding layout is key, and that's why understanding FlexBox is imperative. FlexBox operates on the concept of two axes. The main axis, defined by the flexDirection prop. On the web, the default value for flexDirection is row. In the case for React Native, the default is column. And then the cross axis. This runs perpendicular to the main axis. In React Native, the default cross axis is the row position. Flex is a key prop that will make the component it applies to proportional to the value assigned to it. In the web, this value can be a double digit, but in React Native, it can only be a single digit. Flex is what is utilized to define the size of the container that holds the items within it. For example, if I set components to flex value of 3 versus 1, it will take up 3 times as much space as its default value. To achieve a basic layout, you can utilize a combination of the following props: flexDirection, align items, and justifyContent. As mentioned before, the flexDirection will determine which axis of the flex container the children will display. The values that flexDirection can be set to are row, row reversed, column, and then column reversed. So if the value is row, the children will display left to right, and the default in React Native, which is column, will go top to bottom. Now the align items prop will manipulate how children are aligned in the cross direction for a flex container. So in the case of React Native, if items are being displayed vertically, this prop will handle how the items are displayed horizontally. The values for align items are flex start, flex end, center, and stretch. I want to emphasize that for React Native, the default is stretch, and not flex start like it would be for the web. JustifyContent is the counterpart to align items, because JustifyContent will align the children of the FlexBox container along the main axis defined by flexDirection. Based on React Native's default to column, JustifyContent will by default align items vertically. The values that can be applied to JustifyContent are flex start, flex end, center, space between, and space around. Okay, great. Now that we've established our foundation for FlexBox, let's apply some of these concepts and see them in action. As you can see, we have one parent view that is set to styles.container. So let's start by reviewing our current style sheet in our app.js. Let's remove the instructions object because that style is no longer in use. We currently have a style named container, and that has the following: a flex set to 1, justifyContent and align items set to center, and a background color. Let's change our align items to stretch, and then in our input style, let's remove the width and this margin. We have to remove the width here because when a width is set, it will restrict our secondary axis when it is row. And the same would go for height, with the secondary axis being based on column. Let's refresh and go back to our simulator. Now in the simulator, you'll see that our list takes up the whole screen, and that's because we changed our align item to stretch across the cross axis. and in our case, right now, it is horizontal. Currently in our code, we have our scroll view commented out. And if we were to uncomment that, we will see the flat list takes up a majority of the screen. And that's because we don't have any layout instruction in our code. So in our code, I'm going to remove this comment, and then back in the simulator, we will see the layout's not split like we thought it would be. So let's add some instructions to our code. So let's wrap our scroll view in a view and set that style to styles.halfContainer. Right below that, let's wrap our flat list in the same styles.container. Now we can scroll down to our style sheet and create this style. The style will be an object that has a property of flex set to 1, and we will see that we have split our parent container in half by nesting 2 views inside of it, which means it takes up the full parent. But since there are 2, FlexBox knows to split it in half. Now this wraps up our introduction to FlexBox. If you would like to test the zoom on the scroll view, press Ctrl and click, and that will mimic a static touch, and you can use your cursor to manipulate the image. To exit, you will press Option.